Okay, so this time we are going to take a look at how the specularity works on this tree, specularity and also the roughness. I will try to cover both in this session. If it gets too long, I will split this into two. First, going for specular, then going for roughness, or the other way around. So first we'll see how the specular works on this tree. Okay. From the last video, there's a small change I did on this. Excuse me. So it is called a time of day. So time of day is a free plugin that comes with Unreal Engine 5.5. So you just have to activate it under plugins. So go into edit plugins, and when you search for maybe day, yeah, so day, it's called day sequence. Okay, so turn it on. So this is experimental, but you can use this for testing out, or on your personal project, but they wouldn't recommend using it on your if you're trying to make a game and going to sell it, because it is still experimental. So I think this one should be available for 5.6, because this is 5.5, so that's why it shows experimental, I think. So installing this is very easy. So you just remove all the lighting, like exponential height fog, your post process volume, everything from the scene, and delete them, and just drag and drop this from this. So go to place actor, then you have to go into all, then search for day. So this sun moon day sequence actor, so this is the one you need to drag and drop into the engine. Okay, so once you drag and drop it, so it will look like this, because I moved it out of the way. So this sun moon actor look like this. So this is just like a light, like a skylight, but this is the actor. So that's all you need in the scene. You don't need anything else, and it gives it some nice lighting here. So the advantage of this is that you can easily set up the change the time of day. So you see here there's a slider which you can use to change the time. So when I move it to either side, it just changes the lighting. So now it is like around 22 hours. We will try during night, and moon comes up, and I haven't played around with this, setting the lighting intensity and all, but now it looks too bright. But yeah, this is something, so I need to try it out. So time of day, for now, for this tutorial, I will set it up around 9 a.m. because for 9 a.m. We need some realistic lighting that can hit the trunk from a side. Okay, so 9 a.m. is good for us. So I'll keep it like that. So now we can see really good specular highlights on the tree trunk. Okay, so continuing with the specularity. So how do you see the specular, like if it is working or not? So you go into a buffer visualization, and you can go into specular. So when you turn on specular, now it is just a flat color. Okay, so this is not what I need. So I want to do some nice details on the specular highlight. Also, when I go into buffer again and try to turn on roughness, so roughness is pretty good right now. Okay, roughness is directly taken from the blue channel of neon map. So that is where we exported it from Substance Designer, if you remember from the last video. So everything is working. So roughness is totally good on this tree. It may be too rough, because white means rough and black means smooth. So in our case, we are going to focus first on the specular, then we'll come back to roughness later. Okay, so go to lead mode. Now how to control this is a matter of using combining various combining two two textures, two parts of the textures, that is ambient occlusion and also the roughness. So we'll use these two as masks to control the amount of specular we need. So we'll first open the material, go into the master material, and we open the M tree, M_tree, sorry, underscore tree. Then what we have here is the material we created in the last video. So everything comes from this master material. Okay. So we were working on the tree leaf yesterday. Not yesterday, actually it was recorded yesterday in the last video. So we will continue from there. But for the specular, right now I'm going to add it into the tree trunk. Okay, so double click on this and it opens in a different tab. Okay, so that is for the trunk. Okay, this is the base material for the trunk. So we haven't added anything else into it because we don't need color variation or anything. But specular has to be done. So specularity should be the same for both the. I mean, you can keep it different, but for now we will keep the same. Okay, then we will change some of the settings in the material instance just to get that variation. So the base will be the same. So for this, first of all, we need to create a material function for specularity. So what should we need? What do we need for this? So we are going to create a material function for specular. So go into material advanced material function. So I'll name it as mf underscore. This is for generating the spec. Okay, so maybe specular generator. You can name it like whichever way you want, is fine, like it doesn't matter. Okay, so double click on this and drag and drop it here. Then like every other material function, this opens with a output and we need to create the inputs, right? So first input is just type input, function input. We need two of these, Control D. So first one, we should name it as roughness. Okay, so we are using roughness and also the ambient occlusion. Okay, so this is AO, and these two have to be scalar because we are only using one channel from the texture. Okay, so roughness is blue channel from normal map, and AO is the alpha channel from diffuse. Okay, there's a small problem here because the leaf part of the tree don't have ambient occlusion because the thing is we use the alpha channel for subsurface, so that is perfectly fine. So we can just uncheck use specular, okay, for the leaves. So make this into this one is make this into a function input scalar. Same thing for this input scalar. Okay, there is a little bit of lag here. Okay. Then I'm going to keep it clean as we did for the previous ones. So for the roughness, I'm going to invert it. Okay, so for invert, you should use 1 minus node. Sorry, 1 minus node. So it will invert it. Then I'm going to create a named reroute and name it invert roughness. So this will be the inverted roughness. So roughness invert means like wherever there is white, it becomes black. Wherever it is black, it becomes white. So just the invert. Okay, and this one should be the just the AO named. Just name it AO. So that's pretty much it. And we can keep this in a group we can call it just inputs. We just give it some crazy color. You can use it like which is not bad for the eye, to be sure. Okay, so we have the inputs already defined. Now we need to use this to get some controls for the specular. Okay. So what are the things I need? So I need to control the specular power first of all. Okay. So you can call it like specular, maybe saturation value. I don't know. So you can actually call it like anything. So the value can be like input, specular. So we can actually get some input, function input. So we need two of these function input. Both have to be scalar. Okay, we cannot use vector here. Scalar, and this one is also scalar. So the first one, I will name it as spec desaturate. Spec desaturate, and this one is, I will call it as spec power. My computer is not that good. It's pretty old right now, so you might see some little bit of lag. Very sorry about that. But if I go slow, it won't be that hard. So here I just changed the sort priority. So input roughness 1 is good. So input AO we can keep it as 1. So it will be showing as the second input item. Then here what we need to do is we need to connect the outputs from here into something should happen. Okay. So the inverted roughness, I want to combine that with the ambient occlusion. So how will I do that? So just get the named in roughness and named AO. So I'm going to combine these two into through a lerp. Okay, so linear interpolate. Interpolate. So I'm just combining these two. So lerp actually is a kind of blend node. So it blends between two based on the alpha power here. So by default 0.5 is good, because now these two will be combined based on a 0.5 alpha value. That means you will see a result that is half of these two. Okay, it's kind of overlay effect, but we're using lerp. This is a really good way to control the opacity. Okay, so this output comes to, I'm going to name it. So this is roughness and AO. You can actually name it like whichever way, like it doesn't matter. Roughness and AO. So it's a combined roughness AO. So we will use this for the entire section of this here. So this is, we can just name it as rough or rough plus AO. So this is roughness plus AO combined. Okay. So now what we'll do is, so rough AO, we'll use the named. So I'm actually using this method to keep it clean. There's no other reason why it is kept like that. So this we can keep power here. So I'll be using it separate. So right now we need to combine this. We need to control the value of this roughness AO by using a multiply. Okay, so I'll just multiply these two, rough AO with the desaturate. So whatever value I give here, it will control the amount of roughness. Okay, then I'm going to pass it through a clamp. So when I pass it through a clamp between 0 and 1, so it won't go too low down, or it won't go too far up. So it'll be within control. Okay, it is somewhat similar to the saturate node, but here I'm using a clamp. Then we need to use the input power. So that what I can do is, if I want to combine this with the input spec desaturate value, I need to use a lerp. Okay, so again, interpolate, linear interpolate, and this power can be the alpha, and this clamped value can be B. Okay, so if we give 1 for this, it will show the clamped value. Okay, clamped roughness AO value, and if it is 0, it will show just black, because if you use a constant with value 0, that means it's black. Okay, so using the lerp, I'm going to push it out into the output. So this is basically how the spec is going to work. Okay, so this is spec control. You can just name it anything. So I'll just color this into black so that it looks somewhat different from the others. That's all. So this is for this spec control. Okay. So I think I will need a switch for this. So the switch we can do in the main material function for the trunk. Okay, and for the leaf, both. So so here the spec generator, I'm going to drag and drop into the main material function. So what are the inputs we need? We need spec power, we need spec desaturate, roughness, and AO. Okay, so I think I'll make a small change, because I need the textures at the top. So texture inputs at the top. So these two, 0, 1 is good. Then this has to be 2, sorting order, and this has to be 3. So if you're doing this, and if you look at the material function, you can see both textures are at the top. Okay, so these two are like all of them are scalar parameters, but first two are the texture inputs. So we need a roughness. So named roughness in, it goes here. Then we have ambient occlusion. So named railroads AO in. Okay, occlusion. Then we need two scalar parameters, spec desaturate and spec power. So press S on the keyboard, left click, and this is a scalar parameter. So I'm going to use the same name, spec desaturate, and I need to give it a default value. Okay, so for this for the spec desaturate, I'm going to give it 0.5 as default, spec desaturate, and I'm going to give this spec power. So just Control D and change this to spec power. Spec power, you can use the same 0.5 is fine. Then put it on here, connect it to the spec power input. Then I will create a named group. So for this, I will name it as 3 underscore for now, 3 underscore specular controls, and this can be 1, and then this is 3 underscore specular controls 2, because we don't have anything else in for the tree trunk. That's why it's looking empty. Then the specular generator will have to result something. Okay, so this has to input here. So this is named railroad. This name is specular result. Okay, so drag and drop here. So we have the specular control. Name it. This is trunk specular. Okay, for the leaf we will use another one that is called leaf specular. You can use the same nodes for that. So named reroots specular, and just make some space. Connect this to spec. So we have this specular controls for the tree trunk. So once I save it, see that something gets updated. Okay. Now we will see how this thing looks for now. Go into buffer visualization, then go to specular. You can see that it's already working. Okay. So now the spec is like wherever there is a because ambient occlusion is being multiplied, you can see that wherever there is a depression, there is something going in, it gets less spec, and the surface is all bright. Okay. So now we will adjust the values. So now go into materials and the tree trunk. So this might be a little bit weird first, because for each of the material we need to adjust the levels. Okay. So one is trunk leaf, then for this we will add 2 for roughness and 3 for the specular controls, because we don't need color variation for this. That's why. So spec controls, specular desaturation and specular power. So specular power, you keep it 1. See that it's getting bright. Okay. 2. Yeah, I think I can go like unlimited. So there is not much. So I haven't clamped this. You can clamp the value later if you want. So now so 0.5, I will check how it looks in the viewport. Lit. So now if I need more glossiness, okay, if you can check here. If I increase this to 1, see that it's getting more glossy. Okay. But the inside part of the trunk, like for example, yeah, this is a nice spot to check. Sorry about that. Nice spot to check. So now here, if you look closely, like this part doesn't have much spec. So go into lit buffer, specular. See that it is getting dark inside, but the sides are having a little bit of brightness. So like these are all micro details you can go into when you're working on the when you're polishing the material. Okay. Okay. So the leaves are a little bit more glossy than the trunk. Okay. Right now, when I'm looking at this angle, let me try this leaf. Yeah, this leaf is good. So if you look at the angle of the sun, this is kind of very rough right now. So if you go into buffer, specular, see that it is just white. So like it doesn't have much control. Okay. So we'll use the same technique for the leaf. Just save this material instance for the trunk and saving. So going to m_tree, we are going to use this same spec control. Okay, so we can use the same material function for the leaf. So I'm going to open the leaf material function. Open this and drag it here. So mf tree leaf. Okay, so we need to create something here for the spec. So from this, I can even drag this in because it's all the same controls. Control C, go to mf tree leaf, Control V. So we got the trunk specular. So change this name to leaf. So we don't have to change the material function. We can use the same material function, but yeah, you just have to change the names. That's all. So this specular comes out here. Just add it to right here. So named parameter, named reroots specular, just like we did for the trunk. Add it here. So that should make it more, that should give it more control over what you want to achieve. Okay, so tree trunk, when I open the tree leaf material, we'll drag it here. Okay, so this is a material instance for the tree leaf. So go into lit buffer and specular. You can see that now the leaf is showing like a really good specular value. Okay, for some reason this one is going black. I'm not sure why. Yeah, maybe that's because we use the ambient occlusion in case of the trunk, but here we don't have ambient occlusion. Okay, so we have to make a small change to the way the leaves specularity works. So let me go into buffer and specular, and for the tree leaf I think we need we cannot use the same function. Okay, so we need to make a change. So for the master material, so this MF specular generator, rename this as trunk. Okay, and just make a duplicate, Control D, and this is leaf. We need a separate function for the leaf, okay, because we are going to remove the remove the ambient occlusion from it. So I'll just close these two because these two are done. So for the leaf specular, so this is the specular generator for the leaf. Okay, yeah, for the leaf. Now what we need to do is, you see this, there's an AO control here, right? So this AO is actually called in as the subsurface. So for the subsurface, since we don't have any like, it is not fully covering the whole leaf, it's only showing through the leaf part, so the stem is being hidden. Okay, we can use this for some special effects, like if you want to show if you want to remove the leaves, like in case of snowfall or stuff like that, because this is a tropical tree. Of course there won't be snow, but if you're using it on some other tree, like a deciduous tree, like a maple tree, you can use this technique to remove the leaf. Okay, so I won't be showing it in this video, but I'll keep it for later. So for the input, what we can do is, so there's a quick fix for this. So I'm not going to change anything here. Okay, so input AO, instead of this scale, this input AO value, what I'm going to do is, actually we don't need to change anything. Okay, so in the M_tree leaf, okay, here what we can do is, we don't even need to change anything. So this subsurface in, okay, because instead of AO, what we can do is, I'm going to assign a value to it. Okay, so just use a constant and give it a value of 1 and assign it here. So that literally fix it. So you don't even have to do anything. It is saving. Yeah, so it literally fixes the problem. So you don't have to you don't need to use a separate material for that. I mean, separate material function for this. This can be reused. Okay, so there was a slight change in on my side. So for the leaf specular, we don't have any control for the AO because we don't have AO. Okay, so we can just rename this as MF specular generator. We don't need a trunk. We can just keep it like specular generator. That's it. And we don't need this spec generator for the leaf. We can actually delete it. Yeah, so that's it. So we have a leaf specular, and we have everything connected here. So when you look at the material instance, we can just try it out. So now the spec is really working really well. So for the leaf, it looks like this, and for the trunk, it looks like this. Okay, trunk is using ambient occlusion, and for the leaf, since we don't have ambient occlusion, we're using only the roughness. So let me do some adjustment here. So spec power, spec desaturate. What does that do? When I move it to 1, it is giving it kind of brightness. Okay, it makes it more bright. When I keep it like 0, it makes it like pure black. So that means you can keep the spec desaturate to around 0.5, and this spec power you can use it to control. Okay, how much specularity you need for the tree. So yeah, so that is how we control the spec. Next we'll see how to use the roughness. Okay, so here I made a slight cleanup of all the material functions we did just now for the leaf and the trunk. So if you look at the material instance for the leaf, I just organized them properly, like numbering them properly, all the parameters. So number 1 goes to trunk leaf choice, like you wanna choose between trunk or leaf. Number 2 is subsurface. This is specifically for the leaf. Okay. Then number 3 is albedo controls. So for the color variation, tint variation, all those stuff. Then number 4 is for the specular. Then next part goes to leaf textures. So earlier it was just leaf. There was no textures specified. So I just made it much more clearer now. Then for the trunk, if you look here, so number 1 is again same as the trunk or leaf choice. Number 2 is specular controls, same as the leaf. Number 3, I don't have a number here, so it is just a trunk textures. Okay, so what we need to do is now as number 3, I'll be adding the roughness controls for the trunk, and for the leaf it will be number 5, roughness controls. So you can see the roughness can be after the spec or before spec, but since we already did specular, we can have the roughness as the last one before the leaf textures. Okay, so going to the main material, master material. Now we will do the roughness pass for the leaf first, then we go to the trunk. Okay, both will use the same material function. So double click on this for the material function for the leaf. This is the main material function for the leaf. Okay, so currently roughness is being taken from normal map blue channel. So roughness goes here, normal map blue channel. We are going to make a slight difference. I mean slight change because we'll get more control over it. So right now we don't have any control over roughness values. So how to see that is go to buffer and go into roughness. So roughness is like right now it is just coming directly from the texture. Okay, there's no adjustment possible. So that's what we are going to change now. So we create a new material function. Again, go to material, material advanced function, MF roughness. You can just call it MF roughness. That's it. You don't need any other fancy name for this. And double click, open the material function. So it is just again the same output viewer there. So here what we're going to do is we are going to create specific parameters for the roughness. Okay, so first of all what we need to do is we need some inputs. So input, this is the function input. We should use scalar. Okay, so scalar. I need about let me see. So first input texture. Okay, then we need one for strength for the roughness value. Then we need to have a roughness contrast. So another one. Then we can have a minimum roughness and also maximum roughness. So these two can be lerped. We can use a linear interpolate node to adjust between these two. Okay, so we need about 5 scalar parameters as input. I mean scalar input. So this is 1, Control D, 2, 3, 4, and we need one more, 5. Okay, so for the first one, I will name it as the roughness. in. Okay, this can be sort priority of 0. Okay, next one is we get like a strength. Roughness strength. You can even say strength. You don't need roughness because it's all about roughness. Okay, we keep it simple. That's strength. Sort priority 1. This one is contrast. Sort priority of 2. Then next one is this is like a max, and sort priority of so what is this one? 2. This is sort priority 3, and this is min. Okay, sort priority 4. So we have all the inputs needed. So we'll keep these two to the side for now, and these two somewhere over here, because we'll be using the whole network to create the effect. So first of all, so we need to multiply this input roughness texture that is scalar, that is found in the non-map blue channel, and we should multiply it with the strength. So that is how we adjust the value. So press M, left click, and multiply this with the scalar value. Okay, so that we can adjust the roughness brightness. So that will be the roughness strength. Then next one is contrast. Is always better to get connected with a power node. So just right click, power node. So exponent, you can keep it as 2. You don't need to change it for now, but because we are going to connect this contrast value here, scalar. So base, exponent. So now we'll have control over brightness and also the roughness contrast. Those two are good. Now we need to increase this by a factor of 2. Okay, so we can do that by multiplying it. So again, press M, increase this factor by 2, because we are not going to change changes in the middle instance, because this is actually fixed. So now it's going to multiply it by 2. Okay, then I need to clamp it between 0 and 1. I can either use a clamp node or a saturate. So here we will use saturate. Saturate is like a very weird node in Unreal, because the name says so much of difference between what the real output is. Okay, so saturate node, clamp. Then we are going to lerp between the min and the max. So this is where we'll use these two nodes. The input this min and the max. So we need a linear interpolate. Linear interpolate node. So the alpha will be taken from this saturate. Okay, whatever value we have here will be taken from the saturate node, and it will fluctuate between the min and the max. Okay, so max will be B. So we can move it down. We can use max here as B, because wherever there is a like when it goes black, okay, when this thing goes dark, that is when the roughness is more dark, that means when it gets more polished or glossy, we'll see the max. Okay, so that is why this max is connected to B. So here we are manually setting a clamp. So that is what is actually happening, and min goes to A. So when it gets white, that means when it gets more rough, we will see this max. Okay, so connect this to the lerp, and output goes to here, to the output. So this whole thing we can actually group it, keeping it well organized. Sorry, it's getting laggy a little bit. Okay, now let's comment on it and say roughness. So we don't need anything else, just roughness is fine. Save it. Okay, so we have a middle function for roughness. we go into the leaf here, leaf material function, drag and drop the roughness into here. Okay, so we have all the controls for roughness. So the roughness in is the texture. So that is named roughness in. This is coming from the normal map blue channel. So strength. So the rest of the parameters, everything is controlled through constants. So for the constant we will give it like a default value for everything. So I'm going to click 1. Okay, we need about 1 2 3 4. Okay, so duplicate 4 times. 4. And I'm going to convert all of these into parameters. So the first one, I'm going to name it as roughness strength. Second one, roughness contrast. Third one, roughness max, and the fourth one min. So min and max. Okay, save it. So now what we will do is we'll connect these into the inputs: contrast, max, and min. Okay, so we got all of them connected. Now we need to define a certain value for these. So reference strength, I'm going to keep it as 0.5 because keeping as an average. Okay, so contrast, I'm going to keep it as at 1 because if I keep it anything below that, it will go black. So 1 is good because it is getting multiplied with the with strength. So it's a power node. And for the roughness max, I'm going to leave it as 0.9, and roughness min, I'm going to leave it as 0.4. So this is something we need to experiment with, but then only we can find out the best value. Then for the output, I'm going to create a named railroad declaration. Roughness, just call it out. Okay, because it might get confused with this. So like this, then we have a group, can call it roughness, maybe roughness tweaks, roughness controls. Yeah, save it. Then for the material function, instead of this, we need to change this to maybe roughness out. Okay, this out goes here. Save it. So now we will see the change in the viewport. Okay, so we need to adjust this in the leaf. Okay, so bring this into you already have it here. Sorry about that. Then what we need to do is we need to define a group for this. So for the leaf, we already have four groups. So for this, I'm going to use number 5. Okay, so group is 5 underscore roughness strength. Keep it as 1, sort priority. Contrast 2, roughness max 3, and roughness min as 4. Okay, so this is for the leaf. So we have roughness controls here. Roughness strength 0.5 is by default. So I'm going to increase this roughness to maybe 1. So like it will become like pure white. I mean, not pure white, close to white. When I keep it like 0.1, it becomes really glossy. Okay, so we need to change the contrast a little bit. So contrast value increasing it will make it more white. So making it 1.5. You have to find the right spot. Okay, so it won't be perfect always. So this is getting more rough. So more contrast, we can just try increasing it, or reducing it. Increase the contrast. So here I think I'll do it like this. And when I go into lit, you can see that the leaves are getting really glossy. You can actually see the nice glossiness on the leaf. So this is how actually how you control it. So for each asset, it might be different depending on your requirement. Okay. So I'll keep it like this for now. Just for the sake of this video. Yeah, it's like it's pretty good right now. It has nice glossy values. So this is how it looks in sun. Let me see if I can find a different angle. Yeah, for this leaf, you can see that it's pretty glossy. It bounces light really well, but the trunk does not. The trunk is like always very rough compared to the leaf. But the leaves are always glossy. They are more fresh than the trunk. Okay, so let's keep the leaf like somewhat close to maybe this one over here. Then please keep it close to that one. So check how it compares. Okay, so here maybe I'll increase the roughness contrast to 1.5 or maybe 3. Yeah, so this is good. So roughness contrast 3 is good. And then reduce the roughness strength by maybe 0.25. So it gets really glossy now. Yeah, I think that is perfect. So look at the reference and look at this leaf. It looks really nice. Yeah, so look at that. Look at the amount of roughness we are getting, the glossiness. So this is basically how you control the roughness. But default value may not be good always. So you will have to tweak it. Okay, get that nice light bounce, because roughness makes a big difference in the scene. So roughness and also the specularity, both combined. Okay, now let's do the same thing for the trunk. So I'm happy with with how the leaf looks. So the tree trunk, we are going to copy the same reference controls here for the trunk. Let's keep this, close this. The tree trunk, so MF tree trunk. Open it here. Now we need a roughness. So drag, paste it here. So the thing about this is that we have to change the name slightly. Okay. So this trunk is, if you look at the material instance for the trunk, we have two groups: trunk or leaf selection. Then we have specular controls. Then we need roughness control. Okay. So this, what is the number? Number 3. Okay. Number 3, roughness. So just change the value. Excuse me. Roughness, number 3, roughness. Okay, and roughness out. So here I'm going to change this name, reroute to roughness out, and connect it here. And the moment you connect it, I will switch to buffer roughness. Okay, and save this material function, and it's loading. Yeah, so it got applied to the tree trunk. So go to roughness value. Now we can just tweak it. Okay, so I think this is really good because the trunk is always more rough than the leaf, right? So if you look at the reference here, so these two, when you compare this side by side, yeah, this is also a good, like a good example. So look at this leaf here, like it's getting really glossy, but the trunk is not. So even in this angle, you can see that the sun is bouncing on it, but the trunk is really rough. Okay, so this roughness value should be good, I think. When you go into lit mode, yeah, I think this is good. So slight roughness, but it's not that glossy. Okay, so default value is good. Now if you want to tweak it, it's always better to go into buffer and roughness. So making it more glossy, reduce this to 0.1 and increase the contrast to 1.5 or maybe 2. This value to 0.5, back to 0.5 or 0.2. Yeah, so we'll keep it like this. So roughness max and roughness min. So we can actually keep it like min as 0.1. So this will be really glossy. Okay, so when I go into roughness and when I go into lit, see that it's like being wet. So you can use this effect just to get that, that kind of wet effect. Like when it is raining, this could be like this. So we can adjust the roughness min and max, maybe dynamically connect it some way to the TOD system, time of day system, to get that wetness effect. Yeah, but for now I'm going to keep it back to default. Okay, because the trunk, because the default values look great for the in terms of roughness. Yeah, so we created all the the separate channels for the trunk. We created all the adjustment for the color variation. Then we made specular. Then we learned how to make how to create the roughness for the tree leaf and the tree trunk, both separate. So when we look at the material right now, for the tree leaf, we have all these controls. So this make it like a superpower, material right now. So we have albedo. So there's a small problem here. So roughness. So it is coming as for the leaf. I think it is getting overlapped with the trunk, but I will fix it later because we use the same material function for both. But yeah, that is how it looks.